Hello and welcome. In this lesson, we will study the upper bound for a set of real numbers. At the beginning, if we have a set S of real numbers, and there exists a real number, let be U, such that, for an element x belongs to the set S, x is less than or equal to U, then U is called an upper bound of S. Thus, if there exists an upper bound for any set of real numbers, then this set is said to be bounded above. For example, on the line of real numbers, let S be an interval of real numbers, and x belongs to S, and x is less than or equal to U. So, S is said to be bounded above, and U is called an upper bound of S. The set of negative real numbers is an example of the set which is bounded above, where 0 is an upper bound of it, while the set of positive real numbers is not bounded above. So, we can conclude that it is not necessary that a set should be bounded above. And if the set has one upper bound, then it has many upper bounds. That is, if U is the upper bound of S, then every real number greater than U is also an upper bound of S. Moreover, if the set of all upper bounds of the set S has a smallest member, let be V, then V is said to be a least upper bound, or a supremum of S. So, a real number V is the supremum of S if two conditions hold. For all x belongs to S, x is less than or equal to V. And for each positive real number epsilon, there is a real number x belongs to S, such that x is greater than V minus epsilon, and the supremum of S is unique. That is, a set cannot have more than one supremum. To prove this property, let V1 and V2 be two suprema of the set S. Then, V1 and V2 are both upper bounds of S. And since V1 is a supremum of S, and V2 is an upper bound of S, therefore, V1 is less than or equal to V2. And also, in the case of V2 is a supremum of S, and V1 is an upper bound of S, so V2 is less than or equal to V1. Then, by the law of trichotomy, this implies that V1 is equal to V2. Thus, every non-empty set of real numbers, which is bounded above, has a supremum. And this property is known as order completeness. So, the set of real numbers is a complete ordered field. Exercise. Find the supremum of this set. Pause the video and try to solve this exercise. The solution. The largest value in the set is 1, it is the supremum of this set, where, for all n, belongs to the set of natural numbers n, each element in S, has the form 1 over n. And 1 over n is less than or equal to 1. Therefore, 1 is an upper bound of S. And also, 1 is the least upper bound of S, where, for any positive real number epsilon, there is a real number 1 over n, belongs to S, such that 1 over n is greater than 1 minus epsilon, thus, the supremum of S is 1. Now, our lesson of today is finished. See you later in the following lesson.